Andrea,
Yeah.
your new book with Monica Di Fiore on the politics of modeling is coming out in August.
Exactly.
Let's talk about it.
Uh-huh.
Did you write it with Monica?
Actually we edited, though we write several chapters, but we were helped by a collective of very enthusiastic authors who helped us to put together this work.
Is it a book on sociology, on mathematics, on politics? What is it?
A bit of all these things put together, because the occasion for this book was a manifesto we wrote as a group, not all the authors, but a larger group, in fact. 22 different scholars, joined forces in the midst of COVID in 2020, when nobody could get out of the apartments, the house.
Perfect timing.
Perfect time. We had, nothing better to do, and we thought we should do something about mathematical modeling and maybe write a manifesto on good practices, and it worked. 22 of us, put together. Though all these 22 people were different by inclination, political orientation, philosophy, discipline, whatever, we managed to put together, to encapsulate in a bottle of 2,000 words what we wanted to say, and we succeeded in a sense, I think.
And this manifesto, published in Nature, is a call to action. What kind of action?
Well, this boiled down to the exactly was COVID, the casus belli, the occasion, because during COVID, mathematical modeling became incredibly visible in the public arena. So in the public discourse, people started using terminology and jargon coming straight from mathematical modeling, like flattening the curve. No,
yes,
this is typical.
Everybody became an expert in.
Everybody is like exactly. Everybody became either an epidemiologist or a modeler.
Yes.
No, and so the modeler were given an incredible visibility, an incredible authority, in our opinion, excessive authority.
Yes.
So they were taken as a truth machine, and we were kind of shocked by this eruption of mathematical modeling in this uncontrolled and unregulated way on the public agora. So we thought that someone should, say a few words of caution about how mathematical models, especially, are used by society.
Yes. Okay, so they're very useful, but they can be dangerous and should be taken with caution.
Yes, I mean, our everyday life is permeated by some form of mathematical modeling, whether we know or not, because mathematical modeling is not only at the basis of design, manufacturing, optimization, operation, execution of different tasks. So you could talk about invisible models surrounding us. Some models are more visible than others in the sense that they are used for making the policy. But in doing this, some models, which by their nature are supposed to give indication, how shall I say, indicate too much. No, they indicate in a way which presumes that they know, where we should be going, instead of telling people that they indicate where to go if what the model assumes is true. So this second part, which is very important, is often left unspoken, and this may create a considerable problem.
Yes, yes. And it's one of the call action that you state in the manifesto. What people
in the manifesto, we insist a lot on the fact that the conditionality of the message offered by a model, conditionality means this is true if this other things is also true. No, there is a condition behind this, should be spelled out, and possibly different conditionalities should be explored. To look at different a universe of possibility. Because if this is not done, the model may end up constraining a choice and a policy which is non-optimal, which is perhaps what happened with COVID, because maybe I'm aware that not everyone would be satisfied of the way society has reacted to COVID. Beyond the extraordinary success of vaccines, the array of different policies which were put in place in different countries, each country is claiming that this was really the right policy to take, I think this was disturbing to most people.
Yeah, there was a lot of uncertainty.
Yes.
Yes. Yes.
Well, uncertainty was particularly, the victim of all this, because it was I mean, everyone knew that there was uncertainty, but we did not actually act on the uncertainty.
Yeah.
So the interesting things about uncertainty is that you can act on it. No, you can act on it because first you can map on it. It's very important to map the uncertainty, because if you map the uncertainty, you know where you stand. Okay, and then when you map the uncertainty and know its boundary, you can operate on this boundary. No, and you can maybe try to either progress or take decisions which are compatible with the existing level of uncertainty.
Yes. Yes. So operating with uncertainty, being aware of it, and mapping yourself in its field, rather than just being scared and trying to do something precise.
Yes, in a sense, if you really maybe want to stretch it a bit, this is the old Socratic teaching of knowing your ignorance. No, by knowing what you don't know, you can become, in a sense, a better person. I would say, perhaps even take better action. So especially you take action which don't ignore other actors, because imagine that only a few actors, for instance, people with a laptop, can decide the policy. Which in a sense is what happened, because who does mathematical modeling? You know, people who can sit comfortably at home writing software and writing articles. But not everyone is like that, no? So some of the policies which were designed by these people sitting at home, like us, you know, and writing on the keyboards, you know, were not really fit to everyone else. In a sense, no? So there wasn't this kind of pluralistic, collective, well-reflected approach to how we should handle this kind of episode. And this, to a large extent, is also due to mathematical modeling.
Yes. Yes. And it's one thing about the manifesto that impresses me a lot. It's just a couple of page text that then develops into a full section of the book with a chapter for each action call in the manifesto, right?
Yeah, this, in a sense, it was easy, you see? The difficult was the other way around. The difficult was to capture the thought of these 22 scholars, each of which with a lot to say, and constrain it into a bottle which you throw at sea, which is a manifesto, no? The constraining was very hard, but I must say that I must be very grateful also to the editors of Nature, because they did, they were terrible, but they did great work to help us eventually to write something which was understandable to people, which was clear, which could be effectively communicated.
How long did it take to write the manifesto?
The manifesto was written in exactly 60 days, from the inception to publication.
Wow.
60 days.
Impressive. And how about the book?
No, the book took more than the best part of two and a half years.
Wow.
I would say. This was much more laborious.
Wow.
Yeah.
Okay, what is the main message of the book?
Well, the main message, as we mentioned discussing COVID, is some kind of state of exception. What do I mean by that? I mean that there is now a lot of work on sociology of quantification, so scholars who study how numbers are produced, and certain numbers receive a lot of attention. And those are the numbers of statistics, for instance. Statisticians are very reflexive in the way they discuss how they produce their numbers. Algorithm is another area where there is a lot of discussion on how bad or good those rankings and ratings are, and algorithmic. Rating and ranking is also another field where there is a lot of discussion. It's good to rank universities, good to rank city or countries. But mathematical modeling is a field where there is, in a sense, a bit of lack of analysis, for a variety of reasons, because mathematical models are more complex. They use mathematics, to quite a level of sophistication. They tend to be a bit black boxes. Yes. So not many scholars venture into analyzing how those models are produced. So in a sense, they live in a state of exception where there are not really rules, no? And this is also made more serious by the fact that mathematical modeling is not a discipline. Statistics is a discipline, no? With recognized leaders who can, influential journal, fora where they can discuss. Mathematical modeling is done everywhere, no? It's pervasive in all different fields. So there are it's very difficult to have rules for
Yes.
mathematical modeling which everyone would follow.
Yes, and it's so different, and it's in different disciplines, and every school perhaps uses its own custom, and there are no uniform rules also how to build and analyze those models, right?
Yeah, precisely. One author said that what unifies mathematical rules is the difference, the absence of common rules. Yeah, exactly.
Andrea, why are you the right person to deliver this book to the world? Why should we listen to you?
Well, maybe many years. I'm a modeler myself, especially when I was younger. I was doing a lot of it, and at the beginning of my career, I was doing mathematical modeling in the field of nuclear safety, nuclear waste disposal safety, and I was writing model which would predict the fate of radioactive waste over 1 million years.
Oh.
Now I would consider this pure madness. I wouldn't do that, but I did that at the time. So I think that when you do something like this, you have to repent. You know, you have to atone in some way. So maybe the book is my atoning for my earlier sins of hubris, of wanting to predict what cannot be predicted clearly.
Okay. I understand you're influenced by the past to have the motivation to write this book, but what impact in the future you're expecting, or you would want it to have?
Well, I would first of all like people to read the book, or at least part of it. And the book can also be read independently, one chapter, also depending on which author you. Most authors are quite well known, so people may wish to look at a chapter of their preferred author in that book. I don't know, maybe in the book we talk a lot about uncertainty analysis, sensitivity analysis, or other methodologies which can be used to shed a bit more clarity and light on the functioning of this model. Well, I hope that reading the book will encourage people to, modelers to use them more, and society and users of those models to ask for these kind of tools to be applied.
Okay, so enhancing the analysis around the models, the practices of the building the models, using the models, interpreting the models.
Yes, in the book we say a lot about how models should be as much as possible interpretable. The model shouldn't become too big as to be incomprehensible. We would say there should be maybe smaller, shorter models, but with more discussion of their conditionalities and inferences. So spend more time discussing what a model says in a what-if kind of fashion, rather than building a huge model which will answer all questions, which is often what one does, but this is really not very useful.
Yes, it becomes so complicated you cannot even find an error if there is any inside. But
exactly, this is also the case. I mean, the modelers know that.
Yes.
They know, they have the Lubavsky law of computer entomology, which says that there is always one more bug. So the modelers are very aware of the error. But the problem are not so much the error as the fact that when the model grows, at a certain point it becomes so rich that even the modeler forgot what assumptions were made in the construction. No? So they forget some of the conditionalities I was mentioning before.
Yeah.
And this can be a danger for those who use the model, who must be informed of the conditionalities.
Yes. So ultimately, do I see it right? Ultimately, a model is a tool for you to design an action or intervention, a policy, to make a decision, and then you want this model to be kind of mobile enough and light enough to be able to reflect different choices we can make.
Yeah, this is what. This is also one of the subject of one of the chapters, the one written by the philosopher Jerome Ravets. That you use this model can also be used in the context of a discussion, of a negotiation among actors. No, so they can use this model to see what happens when different assumptions are fed into them, and the assumptions are driven directly by the people around the table. No. And in this way, you don't throw away the model. You use a model at their best, but you kind of make use of this plurality of different lenses for looking at the problem, which plurality of actors can bring to bear.
Yes. Well, I can say that I've seen the contents. They are exciting, and I really look forward to getting the book and reading it.
Thank you very much.
Thank you for writing it.
Thank you.